Okay, in this video, I'm going to answer a request that came up today during class, which was about um, problems with diminishing returns. There's no guarantee that I'll put one of these on the test, but I have asked problems like this on past tests. This is a problem in the slideshow. We did this problem in class. Let me back up a little here and show you again the lesson for diminishing returns. We let X be the number of units of advertising bought so far, which may be, for example, um, minutes on a radio show or 30-second blocks on a TV show, or um, maybe appearance ads on a search engine. Then we track with S of X how many units of sales that have resulted from the X units of advertising. The point of diminishing returns comes somewhere in the middle of the ad campaign. So for X less than X sub D, few customers have seen the ad yet, sales are accelerating. More and more people are seeing the ad and spreading the word, and you're getting more sales and more sales for each additional unit of advertising. However, once the campaign has been running for a while, most customers who would want the product have already seen the ad and already decided whether to buy it or not. So each additional unit of advertising only gives you a few more units of sales. And right in between is a tipping point. That's where the rate of sales, S prime, has its maximum. And in order for that to be the case, S double prime must be 0 there. So that's the sort of funny thing. S prime has a critical point. Its derivative is S double prime. So what we're looking for is the inflection point of this sales function. So there you go. The point of diminishing returns for an ad campaign is the inflection point of the sales function S. And this was the exercise that we worked in class. I'm going to work a different exercise Yes, that's set up correctly. Okay. I'm going to work a different exercise now. This is a problem that appeared on a test in a previous semester. So during an advertising campaign, the total amount of money collected from sales is given by this function. So big S of X equals negative 0.5 times X cubed plus 39X squared plus 119. And that's all in thousands of dollars. There was some confusion on this problem about whether the 1,000 applied to the whole formula or just to the 119. My intention was that it would apply to the whole formula there, like I've shown it here with extra parentheses. Okay, we're told that X is supposed to be thousands of dollars that have been spent on advertising so far, and this formula is good for X between 0 and 52. Okay, and we're asked to answer the following questions. Round decimal approximations to the nearest hundredth, as in 12.34. When the advertising campaign reaches the point of diminishing returns, how much has been spent on advertising? And then question B, how much money has been collected from sales at that point? Okay, well, remember, we're looking for the inflection point. Of S. So that means we need S double prime. Well, if we're going to get to S double prime, we need S prime. Okay. So take a minute and compute S prime. Okay, here we go. That should be negative 1.5x squared plus 78x. Well, we need the derivative again. take a moment to compute S double prime. Okay, here we go. Negative 3x plus 78. To solve for the inflection point, well, we're going to need hypercritical numbers. So we need hypercritical numbers. So we will, do you remember how hypercritical numbers work? We will set S double prime equal to 0 and solve. So negative 3x plus 78 equals 0. This is straightforward to solve. Just be careful that you don't lose a sign. So there I've subtracted the 78 over to both sides. Now I'll divide by negative 3. And if you like, you can do a double negative simplification because negative divided by negative is positive. And then 78 divided by 3 78 divided by 3 is 26. Okay. So I'll just go ahead and say, so x sub d equals 26. Now let's be sure that we can answer the two questions. When the campaign reaches the point of diminishing returns, how much has been spent on advertising? Okay, well, the amount spent on advertising, that's what X means, right? X is thousands of dollars that have been spent on advertising so far. So A is asking us about the 26. Just to be especially complete about this, let's write this out. At the point of diminishing returns, well, got to remember how to interpret this. X is in units of thousands of dollars. So when X is 26, that means $26,000 will have been spent. Now we need to set to answer question B. How much money has been collected from sales at that point? Okay, well, the total amount of money collected from sales is given by this function S of X. Then, of course, at the point of diminishing returns means that we need to apply S, apply the function S to the X value that we found, which was 26. Now, just so there's no confusion, this expression for S is written assuming that X is in thousands of dollars. So I want to do S of 26, not S of 26,000. That's something that students sometimes get confused about. If the variable is assumed to be in particular units, then you should always make sure that what you're plugging in is on the same scale matching the units that the variable is assumed to be expressed in. Okay. Let's calculate this. I'll show you 2 or 3 different ways to do this. So one is to just type it directly. So negative 0.5 times 26 to the power 3. Oops. I left out my times. So let me do second insert and put in times. Okay, plus 39 times 26 squared plus 119. There we go. 17,695. So I'll just write that down, 17,695. Now, before we go on, let me show you a few other ways to use the calculator to get that number. Okay. One option is to go to the y equals screen and clear out whatever else happens to be in there and type in the function that you want, which in this case was negative 0.5 x to the power 3 plus 39 x squared plus 119. Now I'm going to actually use the graph here. Let me go to the Windows screen, and x is supposed to go from 0 to 52. So let me stick to that, 0 to 52. And I don't know, let's put a tick mark every 10. Then I'm going to go to the zoom menu and go down to where it says zoom fit and hit enter there. And the calculator will do some calculations and fit the thing directly onto the screen. So now if I want to plug in x equals 26, I can actually, oops, let me go back to the graph screen. You have to hit the trace button. Right there it says trace. And now, oh, well, actually, there you go. X equals 26. And you can read the 17,695 from right there. Another option is that once you've typed it in, you can actually go here. So I hit the alphabet button and then this button, and I'm going to go to this func menu. Nope, that's not it. I want to go to the yvar menu. That's over here. That's this button. I typed it into y1, so I'm going to do y1 and then use function notation as in Lagrange's system and do y1 of 26. And there, that's also computed 17,695. So there's several different ways to do this calculation and check that you've got it right. Okay, so now that we've got the 17,695, let's actually write this out. Oh wait, yeah. So at that point, we need to interpret this number, and let's double check the units. Yes, so the result of x is in thousands, sorry, the result of s is in thousands of dollars. So at that point, now we have to be a little bit careful here. I need to multiply this number by 1,000, which means that I need to hop the decimal place 3 notches to the right. So 1, 2, 3. That means I need to put in 3 zeros. Let's put in some commas to make this a little easier to read. And there you can see $17,695,000 in sales will have been collected. Okay, now one or two last things here. I'm not going to require you to do this, but if you wanted to confirm that the hypercritical point is an inflection point, well, you could put in some test numbers. So, and since we're checking concavity, we'll plug the test numbers into S double prime. I'm not going to write it out as a table, I'll just write it out as equations. So let's test 0. That'll be over here. S double prime of 0 is 78. So that means that S double prime is positive over there. And S double prime of, let's say, 30, well, let's see here, negative 3 times 30 plus 78, that's negative 12. So S double prime is negative there on the right. Remember that S double prime tells us concave up, concave down information. So over here on the left, S double prime is positive, so S is concave up. Here on the right, S double prime is negative, so S is concave down. And that means that right there, S really does change concavity. So yes, the hypercritical point we found is an inflection point. Going back to the calculator, I can call up the graph, and you can see it's a little hard to see this, but the function is concave up over here, and it's concave down on the right. So somewhere in between, it must switch back and forth, and that happens to be at the 26 that we found. And it's hard to pick that out visually. I mean, it looks like it's going to be somewhere here in the middle, but as far as actually picking it out exactly, that's difficult to do. So that's why it's good that we have all of these calculus tools. Another thing that I should warn you about, it happens that the 26 is exactly in the middle of the domain. I noticed that a couple of problems on Hawks do tend to work out that way. Be careful about that because it's not always going to be the case. You do need to look for the hypercritical number. Make sure that you're solving S double prime equals 0. If you really want, I could explain to you how that perfect middle business happens, but I'm not going to go into it in this video. Okay, so again, here we go. This was an example of a point of diminishing returns problem. There's no guarantee that there will be a problem like this on the test, but I have asked problems like this in the past.